Hi, welcome to Placement Cell app. Um, you have straight on some authentication system for registration, login, using some reCAPTCHA checks as well. But I'm gonna go straight to the crux of this app, that is authentication. And also, you can forgot the password and try to recover the password using some recovery email, your original registered email. But essentially, I'm just gonna log in. Currently, I've disabled the reCAPTCHA, but we can enable it. So once we get logged in, then we can see more buttons like students, interviews, reports, external jobs. So firstly, on this screen you're seeing the paginated list of students. Let's say a particular student who was created with some particular details. You can delete the student, or for this student you can add some interview sessions from here, or you can already update the session of his status of his session. So let's try to add an interview session. So he's already a part of this interview, but maybe we want to put one more interview for this candidate. And we can see once the page refreshes, right, it's now part of 2 interviews. From here itself you can try to edit the status. So let's say he cleared the interview and it remembers where you came from, it will land you back over there. So now you can see he cleared the interviews. Again, we can go back on the screen, and so yeah, now the candidate has 2 interviews. Similarly, now in this way you can also just enter your details and it will try to create a student for you. So an empty student will be created. You can delete a student, you can delete a particular interview session of the student. So for instance, this interview session of this candidate is deleted. You might face some refreshing issue because of caching, but if you just refresh it after 10 seconds, it should update. So it has updated. Now we have similarly from interview side, you can create an interview of a particular details, some timestamp. Then once you click on create, an interview will be created like with these details, and you can assign students to that interview, or you can delete this whole interview object. So let's say we just try to add a student to this interview. So currently there's just one student added. Maybe we want to add this student as well. So we have added. Now we can see 2 students. If we refresh once more, we will, because of caching, actually this result is a bit stale, but if you refresh it, when the cache refreshes, it will be there. Again, you can edit the status of this. So yeah, you can create sessions, add session, edit session, delete session. Then also there's the paginated list of interviews. Then we have reports, where you can download the reports. Let's fetch the reports, now you can download it, and now this will be a CSV file you can open, like a pipe delimited file. And then external jobs API, which is showing you jobs of paginated list from add Zuna API. So 2020 results at a time, and you can click this to open the actual job profile. So that concludes the video demo. Thank you very much. Discussing the general architecture of this app. So essentially a user requests our front-end server for React single page application. He receives it. Then using that React single page application, he interacts with our Node backend and can receive responses from our backend. Now our backend might be referring to the cache, and if there is a response from the cache, it will directly get the response and return the response to user. But if there is no cache, or there is some write kind of flow, then it might actually refer to the source of truth, which in this case will be this 3 different kind of databases: Postgres, MongoDB, and even Azuna Jobs API, third external API. So we are currently using authentication related data in MongoDB. We are storing all the interview student related data and all their relations in Postgres, and we are having external jobs API here. So essentially our backend can interact with these source of truths if our cache doesn't have the data. Now let's see how does our cache workflow works actually. So there are two kind of scenarios, like a reading and a writing one. So just discussing the reading scenario right now. So let's say our cache already has the data. So if the user requests some data, backend receives the request, the cache has the data, it responds to the user. But what if there is no data in our cache? Then user must have requested, node must have asked, then cache must have responded that there was no data, like store data in cache. So our backend will now go to the source of truth, which could be these two, three different source of truths. It can respond to our backend, then backend can now fill this cache and then return a response to the user finally. A standard write through cache approach. So also talking about the writing part in this. So for writing scenario, some update or delete request comes over here. Then basically, since we are gonna write, so we're gonna update, so cache will become invalid. So basically we come here, update our refer to our MongoDB and source of truths, do the updates over there, gets the response, and then try to update our cache with the response, or even delete the whole cache for that particular entry, and then return a response to the user. So these are the two write and read related cache flows which we have. Some schemas, basically we have student and interview schema because this is in Postgres. So I chose relational mapping here. So we have these kind of fields: student ID, first name, last name, and batch. ID automatically gets created as a primary key. Now interview or ID also exists as a primary key. One interview can have multiple students and one student can take multiple interview. But to have a bridge object between them, I have a mapping called a session. A session is a unique mapping of a student, an ID, and it can have a couple of status. So this is the mapping for student interview and their sessions. And now for authentication schema, I have similarly some mapping, which is basically the admin details, how they can log in the platform. And if they want to reset their password, then there is some reset token related details. So this is in relation to MongoDB schema. This is in relation to Postgres, and above I discussed about Redis. Walking to the code flow now. So this is the entry point of the program where we are firstly setting the course, as our React is on a different domain. So the course has to be set up according to this, otherwise the front end being part of different origin will not be able to access our backend, which is on a different URL. Then we configure all our routes, then we set up some default error handler over here and some default 404 file path not found, URL not found. Then we just start our server. In the beginning we are also starting our MongoDB server over here, and yeah, we are also having database Postgres over here and Redis over here, which will be initializing in their respective clients themselves. So we are initializing the database in the respective client themselves and just exporting some sort of function which will just be using that client. So this client never get exported, there's just single instance of it. Similarly for Redis, we are initializing in this file and we're just exporting some functions to access, get data, or save with TTL. This kind of functions we are never exporting this client. We're just exporting so that a singleton instance will remain here. Now, yeah, so let's just go through the different routes which we have in this file. And so this might look a lot, but essentially these few paths are related to authentication routes. These are all related to the student only, the student related CRUD operations, interview related CRUD operations, and these are all related to sessions. So student interview combination. So, and then lastly related to the external jobs API. So you might clearly notice that there is a lot of things written over here, particularly as a middleware. So let's say use cache if stored. What it does is basically it has a cache key, and if there is any data according in the cache, then we just return. Otherwise, it will just pass request to the next middleware. So just look at this. So whatever query type we received over here, that query type we try to get from the cache. If there is any result in the cache, then we just respond. If there is no result in the cache, we just move on to the next middleware. Similarly, just like this use cache, there is also other things like check auth. So this will check that whether your JWT token is valid or not. Similarly, we have some validation kind of functions which have some schema for validation of the request objects, let's say in post request. There must be some message body that needs to be get validated, so that it does. And it is actually a higher order function which is itself returning a function. So if you look at this, it's basically returning a functions which is configured using what kind of validation schema you gave me. I will just try to validate it, and it is using JOI related validation schemas, which are also mentioned over here. These validation models, these are using JOI library. So these are different schemas for at least the authentication part of it that is implemented. Yeah, so validators and even reCAPTCHA, these kind of things are abstracted as middleware. Now going to our routes. So the details are a lot, but I will just try to cover up some few essential points which are repeated everywhere. So student interview related things are all having SQL relational mapping, and some broadly you can see all the functions are like this only, that there is some PostGres related some parsing of parameters which we receive with request. Then we try to query our database using some query, and then if there is any result, if there is no result, we return an error object. If there is a result, we try to save it in our cache. Then we also sometimes also refer to some stored data in our cache. For instance, for paginating all the different students, we need one thing called as the total number of students. This is a particularly expensive query if in SQL you write. So that's why I'm using a cache over here. If there is a data stored in cache, I will just use it. Even if that count is stale, I am still fine. Even if it's a rough estimate, but that's good enough for a pagination perspective. Then basically, whatever after we are done with our business logic, and we must have arrived here when our cache was not there. That means we need to now return after saving our cache. So that is what we are also doing. We are saving our cache and then returning from here. So whenever we save our cache, we need two things, like the key of the cache and the value of like what we want to store against that. And this is like a TTL based saving, so we also needs like how much time you want to save it. So let's say 1 minute, I'm just gonna save this entry of all the different students related data. Similarly, there are other things as well. I mean, it's a similar logic. You try to get the data from the database, you try to validate. If there is no result, if there is an object, you save it, to return it. Interesting thing comes here in deletion of an object. So a student can take an interview. That means that a student is involved in the students table and in the sessions table. Sessions has a mapping between a student ID and an interview ID. So when you delete a student, you need to delete even the interviews related to it. So basically that is stored in sessions table, and that is what we are achieving through transactions. So we are beginning a transaction where we are firstly deleting entries from sessions table for that student, which is a dependency, because you cannot delete student data without deleting their entries from sessions table because it's a primary key. So we first do that. Once that succeeds, then we delete from students table, and then this whole operation is a transaction. If any step fails, we roll back the whole thing. Now once we have done the update in our database, so we need to purge our cache because cache is invalid. So again the similar steps, and then finally return the response. If there is any error, we just return the error. Similarly, we have, yeah, that's all from this side. I just want to show the adzuna part as well. So it's similarly here we have parsing of the input arguments, then we get our inputs, and then we get the API response, and then we see if there is any no response, so we send an error. But in order to rate limit the request to this external API, what I'm doing is again saving the data in our cache. So that is again saved for like 1 hour for this one, and against a key of this. So basically this caching is even like to the level of which page number you are requesting. So let me just show you the key part, because every cache needs a key to get stored. So that cache was related to this part, and the keys formed something like this string, and then like which page number the request was being made and how many items per page you want. So that entry must have stored against this, and this is how we are able to get even paginated levels of caching. One more thing which I want to just show is that this app uses React, so front end is a whole lot different thing in a different folder and deployed in a different server. The whole view layer is cut apart, and these front end and back end interact with REST API based JSON objects. So thank you very much.